y'all. So we're on page 16 in the packet, and we're talking about the unit circle again. It's revisited. So let's go back over some of the things that we talked about yesterday. I'm not going to do all of these. If you do want to get some practice, I'm only going to do numbers 1 and 3 with you in the video. But if you want to try numbers 2 and 4, feel free to do that and check online later to check your answers. But what you're being asked for on this first section is all 6 trig functions. So as you remember from yesterday, we talked about sine, cosine, tangent, and then we also talked about their reciprocals, cosecant, secant, and cotangent. So now what I'm going to do on number 1 is, first of all, locate where 2 pi over 3 is, and hopefully you know that by now, is at 180 degrees right over there. So what I need to know is the actual coordinate, and because it's a 60-degree angle, I know that the coordinate for that is -1/2, comma, root 3 over 2. So now, having said that, sine of theta is what I need. I also need its reciprocal, which is cosecant of theta. I need cos of theta, and its reciprocal, secant. I need tan of theta, and its reciprocal, cotan. So sine of theta will simply be your y value, and our y value on this angle is root 3 over 2. Its reciprocal will be 2 over root 3, but we do have to rationalize it, and after you do, you should get 2 roots 3 over 3. So there's your sine and cosecant values. Cos, remember, is your x value based on your coordinate, so x is simply -1/2. And its reciprocal, secant, will be simply -2. Now tangent is going to be, remember, y over x, or in other words, sine over cosine. And in this case, you do have to do a little bit of work. Sine is root 3 over 2, and cosine is -1/2. So once I simplify after I multiply by the reciprocal of the second fraction, I should end up with -root 3. And the reciprocal of that will be -1 over root 3. But again, I do have to rationalize, so that's going to give you -root 3 over 3. Those are all 6 trig functions. Okay, moving on to number 3. 3 pi over 2 is, remember, at 270 degrees right over here, and your location, your coordinate for that is 0, -1. So now, again, I want to look for all 6 trig functions. So I want sine of theta, I want its reciprocal, cosecant, I want cos of theta and its reciprocal, secant, and I want tan of theta and its reciprocal, cotan. So again, sine is your y value, so y is, in this case, -1. Its reciprocal is still -1. Cos is our x value, that's 0. Now just be careful here, because really, technically, 0 is simply 0 over 1. Now if I take the reciprocal of that, what happens? Okay, so I end up getting 0 at the bottom, which we all know now is actually undefined. So there is no secant value, it's undefined. Tangent, again, is sine over cos. And sine in this case is -1. Cos is 0, and again, we're running into that same problem. So again, because the 0 is at the denominator, we know tangent is also undefined here. Okay, cotangent will be the reciprocal of this fraction, so 0 over -1, which is simply 0. So those are your trig functions. I'm sorry, trig values. Okay, now what we're going to do, that was just a review, but now what we're going to do is look a little bit further and really analyze sine and cosine a little bit further. So now we're going to go back and talk about domain and range again, but now in terms of sine and cosine. So now if I look at the unit circle, so a couple of things. One of the things is that the number of radians that I have on the unit circle is actually not limited at all. I am not stopped at all from continuing spirals, okay? Either direction. I'm not limited in the number of radians I can actually explore. the meaning behind that, what that means is because you can actually continue whichever way for however many degrees, is that the domain for sine and cosine, domain always refers to your angles themselves. What that means is because I can continue forever and ever around, then domain for sine and cosine both is all real numbers. I can continue no matter what. There's nothing that's going to stop me from going through several revolutions. Okay, both ways, negative and positive direction. Now range for both sine and cosine refers to your x and y values that are on your coordinates. Now here's the thing, if I pull up my unit circle again, I'm not limited by the number of radians I can explore, but I am limited by the length of my sides, of the triangles that we've created. So because I'm limited this way, really what I'm limited in is my range. And the range, again, refers to your coordinates, what I have in light blue here. So take a look around the unit circle and look for the smallest, the very smallest value in your coordinate. And if you look through, your smallest is actually -1. -1 is the smallest x and y value on the unit circle. So because that's the case, I know that my smallest, or the lowest I can go on my range for both sine and cosine is -1. And the greatest number on my unit circle, again, go through, and you'll find that the greatest number is +1 for both x and y. And so the highest, or the largest number that I can find on my range for sine and cosine is +1. So domain is not restricted, but the range is from -1 to 1. So now if we take that a little bit further, now if I talk about period, so now period is, excuse that, so now period refers to the number of radians that you have in the unit circle before you start repeating. So in other words, if I take a look at the unit circle, we know that typically these are the angles that we typically work with, but you know that we can always talk about more. If we want to talk about more than any radian more than or greater than 2 pi, all we have to do is just continue spiraling. So again, because there's no domain restriction, because my domain is all real numbers, what that tells me is that if I start from initial position at 0 and I go all the way through to 2 pi, after 2 pi, I can continue, but everything at that point repeats. And because everything repeats after 2 pi, then I know everything is everything within 2 pi, within one revolution, is the original period. So I'm going to say that, well, a couple of things. I'm going to say that both sine and cosine repeat every 2 pi radians, which actually tells me that the period for both sine and cosine is 2 pi. So the period is 2 pi. Now here's what we're going to do with that. We're going to explore some angles that you'll be able to locate, but we're going to figure out what their sine and cosine value is according to period, or based off of the period. So what we're going to do is we're going to take sine of theta, and by the way, this is a general form of writing things. So I'm going to take sine of some angle theta, and I'm going to expand it so that we have theta plus the period, which is 2 pi, times the number of rotations. Remember, n is the number of rotations. Okay, we're going to do the same thing for cosine. So cosine of some angle theta will be cos of theta plus the period, 2 pi, times the number of revolutions. Okay, so let's actually figure out what that means. Let's look and see at the examples below to see what that actually means. So number one, first of all, go ahead and figure out, pause the video, figure out where 7 pi would be. Locate that for yourself real quick. So 7 pi, if I start in the positive direction, so this right here is 2 pi. That's not enough, so I'm going to do another revolution. That's 4 pi, still not enough. Another revolution, that's 6 pi, still not enough. I just need another pi, so I'm going to stop right there. That is actually where 7 pi would be located. And if you notice, and hopefully you do, that's at the same location as pi itself is. Now keep that in mind because I'm going to come back to that. Now what I'm going to do is I'm going to expand cos of 7 pi by saying, since it's at the same location as pi, 7 pi can be represented by writing pi plus the period, which is 2 pi, times the number of revolutions we just went through. And the number of revolutions we just went through, if you actually count them out, is 3.5. We went around 3.5 times to get to 7 pi. Okay, so all of this is the expanded form, it's the expanded way of writing 7 pi. Now really what we care about, what we want to focus on is cos of pi, because again, pi is in the same location as 7 pi. So now all we have to find is cos of pi, which is -1, and that would be your answer. And I know you're probably wondering, do we have to actually expand it? Yes, you do. You do have to write it out like that. So to put it in general form, and then go back and evaluate and figure out what the value is. Okay, number 2, again, go ahead and take a second, pause the video, figure out where 11 pi over 4 would be. Okay, so 11 pi over 4 is past 1 revolution because that would only be 8 pi over 4. We do need a little bit more, so 11 pi over 4 is going to be in the same place as 3 pi over 4. Now keep that in mind. Again, it's in the same place as 3 pi over 4. Now if I expand this, I'm going to say that sine of 11 pi over 4 is actually sine of 3 pi over 4 plus a period, which is 2 pi, times the number of revolutions it took to get there, which is really just 1. So, and if you think about it, it makes sense because if you go up to 3 pi over 4 and add a revolution, it takes you to 11 pi over 4. So now all we have to do is, again, focus on 3 pi over 4, find the sine value at that, and because we're looking for the y value, the sine value at the second quadrant, it's going to be positive root 2 over 2, and that's your value. Number 3, again, go ahead and pause the video, see if you can locate -7 pi over 2. -7 pi over 2 will be, and because it's a negative angle, just be careful, we're going to go around this way, so this is going to be, this would be 2 pi. So -7 pi over 2 would be right over here in the same location as positive pi over 2. So now, again, if I expand this, I'm going to write that as, because it's in the same location as pi over 2, I'm going to add to it a period. Now, here's the thing. Because it's a negative angle, I'm going to have to actually add a negative pi over 2 times the number of revolutions. And the number of revolutions was actually 2, because we passed it up twice. And now, if I really look at that, I really just want to focus on sine of pi over 2, which is simply your y value, 1, at that location. Number 4, go ahead and pause the video, locate -15 pi over 6. Again, be careful, it's a negative angle. So -15 pi over 6, just be careful here. If I go in the negative direction, this would end up being -12 pi over 6. I need, because pi over 6s are 30 degrees, I know this would be -13 pi over 6. This would be -14 pi over 6. So -15 pi over 6 would have to be right over here, where where 3 pi over 2 normally is. So again, I'm going to expand this, and I'm going to say it's cos of, because it's normally where 3 pi over 2 is, minus, because again, we're dealing with a negative, so minus 2 pi times the number of revolutions, which is 2. But again, we want to focus on 3 pi over 2, and cos at that value is your x value, which is 0. So there's that. Now moving on to page 17. So page 17 asks you about even more analysis. So now we're talking back, we're going back to even and odd functions, but now it's a little bit different. So now let me give you an example. Let me draw a picture right over here. And let's just focus on some angle right up here in the first quadrant, and I'll call it theta. And if I keep it very general, then I know that this point, whatever it is going to be a positive x and a positive y. Okay? Now, here's the thing. What if instead of a positive theta, we talk about negative angle, negative theta, a negative angle? It's the same theta, it's just now in the negative direction. So now what happens to your x and y? So our x is still positive, our y now is negative because of the location we're in. So now, here's what we're going to do. This is what that leads into. Even functions, remember, if you remember from in the past, we've talked about a test for even functions, and if you recall, the even test, we checked to see if f of negative x is equal to f of x. Now here's where this all comes in. So if we talk about cos of negative x, what that's asking, and again, if you want to, you can change that to theta to make it better for you. But cos of negative theta, now what it's asking is if you have some angle in the positive direction, it gives you a positive x and a positive y if it's in the first quadrant, and we're assuming that it is in this case. But if we go ahead and switch that to a negative angle in the negative direction, then what happens to your cos, your x value? It remains the same. So we're going to say because the x is unaffected, it's still a positive number, we're just going to say that these are going to have the same value, the same sign. So I'm going to say that even functions have the same sign. Because cos of negative theta will be the same sign as cos of positive theta. And because secant is a reciprocal of cos, then it's going to follow the same rule. So that will also be the same as secant of positive theta. Now for odd functions, recall that the test for that was negative f of x equal to f of negative x. Now if I take a look at that, and if I focus here on the first example for sine, going from a positive angle, which had a positive y value, a positive sign, into a negative angle, where y becomes negative, what ends up happening is that your sign, as soon as you go into the negative direction, your sign ends up being a negative value. So what just happened here? If we know that even functions will have the same sign, positive, 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 or negative, 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 then we know that for odd functions, you're going to have the opposite sign, because notice, sign here is a positive and this right here is negative. So we're going to say that odd functions will have opposite signs. And that might actually help you remember a little bit better. So now again, because cosecant is a reciprocal of sine, then that also will follow its rules. So negative cosecant of x. Tan, remember, is found by taking y divided by x. Now, what it's telling you to do is it's asking you to focus on a negative angle. Now, here's my negative angle. In my negative angle, I had a positive x, negative y. So positive x, negative y. Now, if you actually evaluate that, it's going to give you a negative number. So what that tells me is that tan of negative theta is actually negative tan of theta. It's the opposite sign. And again, because that's true for tangent, it will be the same thing for cotan, for its reciprocal. Okay, so now let's actually do some examples. So number 1 tells you that you're given cosecant of some angle, and again, if that bothers you, change that t to theta, and hopefully that'll be better for you. But some angle theta, notice theta is positive, gives you a value of 5 for cosecant. Now, if I scan through what all it's asking for, I can actually fill this one in real easily because it's asking for a positive theta where the other two are asking for a negative. We'll come back to those. But all I have to do for this one is, because I know cosecant and sine are reciprocals, all I have to do is take that number and take the reciprocal, which is 1 over 5. So there's that. Now if I go and if I want to find a negative angle, let me actually draw a picture of what that would look like. So let's just assume that this angle, because it's a positive sine value, I'm just going to go ahead and assume that it's in the first quadrant. So we have some x and positive 1 over 5. I don't know the x value, and actually I don't need it because it's not asking for that. And that's for a positive angle. Now if I want a negative angle, this way, our x is still positive, but our y becomes negative because of the location. So now what that tells me is that sine of negative theta will be negative 1 over 5 based on this new location, because we're talking about a negative angle, and cosecant then will simply be the reciprocal of that, so negative 5. Okay, number 2, it's giving you secant of negative theta is negative 2/3. Now think about where is, actually before I even say that, secant is the reciprocal of cos. So because I'm given that secant of negative theta is negative 2/3, I can go ahead and take the reciprocal of that value to find this answer. There's that, done. Okay, now to find cos of positive theta, I have to really think about this one because I'm given a negative angle, but I'm also, you have to really be careful because cos is a negative x value. I know that cos is only negative on the left side, so in my second and my third quadrant. So let's just say that we have an angle down here, okay, where both my x and my y are both negative. Now if I flip that and I have something now, if I have a positive theta, so let's say something up here, that's a positive angle, right, going this way. What happens to your x? Does it change? So up here in the second quadrant, I would have a negative x and a positive y. So what that tells us is that because we know even functions have the same sign, and based on what I just said, our x is still negative and nothing else has changed. So there is that value. Okay. Number 3, cotangent is given of negative theta. Because it's a negative angle, negative theta, let me scan through. Here's a negative theta, and it's asking for tangent. So I know cotangent and tangent are reciprocals. I'm simply going to take the reciprocal of that. So there's my answer on that one. 1 over root 3. And again, that is a negative angle. Now really be careful because tangent is a positive value. And tangent is only positive in the first quadrant and in the third quadrant, because remember, tangent is y over x. And you'll only get a positive value if both of the signs for y and x both are the same, which is only in the first and the third quadrant, not in the other two. So let's just go ahead and say that we have an angle, let's say down here. Okay, that's a negative angle. And this is going to give us a negative x and a negative y. Now, if I want to find the positive of that, so if I want the positive of that angle, which would be right over here, up here we have negative x but positive y. So now what happens to tan of a positive angle? If I have a positive y, negative x, I end up with negative 1 over square root of 3. Okay, and again, notice that tan of negative theta was a positive number, and tan of positive theta is a negative number. Again, that goes back to the fact that tangent is an odd function, and odd functions have opposite signs. And lastly, because I know tangent and cotangent are reciprocals, I can go ahead and take the reciprocal of that, which is negative root 3. Okay, number 4, let's go ahead and draw that one out. So I'm going to have, sine is positive, it's a positive angle, and 4/5 is what they've given me. So I'm going to take advantage of that. I'm going to say, okay, here it is in the first quadrant. So that's some x value, comma, positive 4/5. Now here's what it's asking you. I'm going to do the second part. I want you to try to figure out this part right here. But if I take my angle, which I'm calling that right there, if I take that angle and I add pi to it, where would it end up? Yeah, so adding pi is basically adding 180 degrees. So this right here will be pi plus theta, or theta plus pi. So now what happens to your sine value here at this new location? Yeah, sine is negative at that location. So all we have to do is take 4/5, which is our original sine, and put a negative in front, because our sine is now negative. So again, go ahead and try this one. Check back with the notes online. And we're going to stop there, guys. And again, as always, let me know if you have any questions. We'll pick up back from here next time. Bye.